Core 3 Review Sheet K Integration 1. The questions on this video are not the same as on the review sheet, but they will help you to answer it. First of all, some integrations by inspection. E to the 2x. What we will do is, instead of integrating, we'll start by differentiating it and then compare the answers. If you differentiate e to the 2x, then you'll differentiate the 2x to get 2, and the e part stays the same, so you get 2e to the 2x. Now that means that when you differentiate it, it doubles. Integrating is doing the opposite, and so the opposite of doubling is halving, so you only get a half e to the 2x plus c. Then we look at our next one, e to the minus x over 4. Again, differentiate it. Differentiate the minus x over 4, you get minus a quarter, e to the minus x over 4. So this time it is dividing it by minus 4. Finding minus a quarter something is dividing it by minus 4. So integrate, you multiply by minus 4, and you get minus 4 e to the minus x over 4 plus c. You can check these by differentiating. When you differentiate here, you get 2 times the half, it cancels out. Differentiate here, you're going to get minus a quarter times the minus 4 cancelling out, and the e bit staying the same. Now, for 2 over x, compare 1 over x. You know 1 over x integrates to ln of mod x. Therefore, 2 over x is going to integrate to twice as much. It's 2 lots of 1 over x. So it will be 2 lots of ln of mod x plus your c. For this one here, we use a very useful rule to remember, which is that if you integrate f dash of x over f of x, it integrates to ln of the modulus of f of x. What you look for is you look for something where when you differentiate the denominator, the f of x, you get the numerator, the f dash of x. Now that happens here. If you differentiate x squared plus 5, you get 2x. So if f of x is x squared plus 5, f dash of x is 2x. So it will integrate to the ln of the denominator, ln of the x squared plus 5 plus c. Let's move on to some integration by parts. These occur when you've got a product in your integral of, and they're two different types of thing. So here we've got 2x cos of x over 2 dx, and then we've got to put some limits in. So to start off with, you've got to decide one of these is u and one of them will be dv over dx. And what we use is u-let to decide which is which. This is an easy way to remember it. You're deciding which is u, and the order is logs, algebra, trig, exponential. So we look at this, there aren't any logs, so the u bit is the algebra for 2x. And that means the dv over dx bit is what's left for cos of x over 2. Differentiate the u, 2. Integrate the cos of x over 2, and it's going to become sine of x over 2. But if you differentiate sine of x over 2, you'd get a half for cos. So we actually need to have 2 lots of the sine x over 2. And then if you differentiate that, you'll get a half times 2, 1, sine going to cos, and so that's going to work. So when you integrate cos of x over 2, you get 2 sine x over 2. Now, this is your rule for integration by parts. It's in your formula book, but still worth knowing it. The integral of u dv dx equals uv minus the integral of v du dx. We just slot everything in. So here's the question. It becomes u 2x times v times 2 sine x over 2. Well, 2 times 2x is 4x sine x over 2. Then we look at the other bit. It becomes the integral of v du dx, v du dx. This times this. Well, 2 times 2, 4, sine x over 2 dx. And notice the integral you're being asked to do, you've still got another integral to do, but it's easier. Instead of having a 2x cos x over 2, notice the x bits disappear. It doesn't matter about the numbers so much. You had an x cos, and here you've just got the sine. Now, when we do this, that stays as 4x sine x over 2. And just the same as here, when we integrated our cos of x over 2, you got 2 lots of the sine. When you integrate the sine, you're going to get two lots of your cos, except that sine integrates to minus cos, because cos differentiates to minus sine. So for this bit, you're going to have minus 2 cos multiplied by a minus 4. So minus times a minus is a plus, plus 8 cos x over 2 plus c. Check this bit by differentiating. X over 2, a half times 8 is 4, and cos goes to minus sine, and the minus times the minus makes a plus, so it is actually working. Okay, next putting in the limits. We put in pi over 2 and naught. Notice whenever you're dealing with any calculus for sines and coses, any of the trig functions calculus, is always in radians. So we slot in pi over 2 in here and 0 in here, but we don't need to worry about the plus c. So we just copy that down with pi over 2 and naught, slot the numbers in. Right, 4 times pi over 2, 2 pi, sine of pi over 2 divided by 2, sine of pi over 4. We want exact solutions, so no decimals, please. Then plus 8 cos pi over 4. Now we need to put the 0 in. Now when you put 0 in, be careful, it won't just always disappear. For the first bit it does, because 4 times 0 is 0. Okay, and then sine of 0 is also 0, so that's going to be 0. But here you've got 8 cos 0. Now cos of 0 is not 0, so you've got to include that bit, don't just forget it. Sine of pi over 4 is root 2 over 2. So you get 2 pi root 2 over 2. You might have it as 1 over root 2, it'd be the same thing. Then plus 8 cos of pi over 4 is also root 2 over 2. So it's another 8 root 2 over 2. And then here, it's minus 8 cos naught. Well, cos naught is 1, so you just get minus 8. Simplify it a bit. Okay, 2 cancels with a 2, and you're left with pi root 2. 8 cancels with a 2 to 4, and you're left with 4 root 2 minus 8. So there's our answer. Now let's look at a situation with LUN. Now in the actual review sheets you haven't got any cases with integration by parts with LUN. But when you come to do review sheet O, which actually tests you, it helps you to do all the calculus work, you will see that there's one to do with LUN there. So it's worth going through this, possibly now. If not, then when you do review sheet O, have a look at it then. So we still use ulate. And notice for u this time is the log bit, it's the ln of x. Okay, and the other part, the 4x cubed, is the dv over dx. Differentiate. Ln of x goes to 1 over x, integrate 4x cubed, power goes up to x to the 4, and divide by the unit power, and you'll just get x to the 4, that differential 4x cubed. Now we just slot everything in as before. So uv is ln of x times x to the 4. Do put the ln bit at the end so it looks more sensible. X to the 4 ln of x is because otherwise if you put the x to the 4 afterwards you can get a little bit confused over what you're finding the ln of. Whereas if we put it this way round, we know it's x to the 4 times ln x. Then you've got your v du dx, so that is x to the 4 times 1 over x. And that's what you left as your integral, the integral x to the 4 times 1 over x dx. At first sight, this looks a little bit complicated until you realize that, of course, that x cancels with one of those x's. And that's why doing it this way with ln works so well. So you're left with x to the 4 ln x here, but your integral, cancelling an x with one of those x's, leaves you with x cubed dx. The integral of x cubed dx, nice and easy, and you're left with x to the 4 ln of x, and minus a quarter x to the 4 plus c. Okay, and that should help you with your review sheet. So good luck.